Welcome to Unit 3. Today's focus is going to be all about triangles. So, looking at the screen, how many of these triangles would you be able to name? Each of the triangles represents a different type of triangle. All right. Hopefully you have your answers in mind. We've got our equilateral, our right triangle, our isosceles triangle, and the last one, if it doesn't fit into any of these categories and all of the sides are different, we're going to call that scalene. Now our focus today is going to be on isosceles and equilateral triangles, and then right triangles are going to be a huge focus later on in this school year. So today is all about classifying triangles. Isosceles triangles are special because they have two congruent sides. And because they have these two congruent sides, the opposite angles are also congruent. So if I'm talking about opposite, I'm talking about like across. So use that definition as we go through our lesson today. Now, an interesting thing happens. There's also the converse of this same idea. So if you notice that two angles in a triangle are congruent, you can also assume that the opposite sides are congruent because, in fact, you have an isosceles triangle. Now here's an example you'll find in your book, number 8. We've got an isosceles triangle, and I can see that because the angles are marked as congruent, which means that our opposite sides are also congruent. You have to pick out the two sides that are congruent to start this problem correctly. Now it asks us to find the length of all three sides, which means we need to figure out what x is. I could just assume that the other opposite side is 35. That's easy. They're isosceles, they have to be congruent. But in order to find the third side, we need to find x. And we do that by setting the two sides equal to each other. So 3x plus 8 equals 35. Solve for x, plug it back in to the third side, 6x minus 5, and you find out that the third side is equal to 40 units. Another useful theorem we're going to learn about a little more in class is if a line or a line segment bisects the vertex angle. So the vertex angle is the one at the tippy top that is between the two congruent sides. If it bisects that angle, so you see this is congruent to this, then the line is also the perpendicular bisector. So it's perpendicular to the line at the bottom, and it bisects it, meaning that it creates these two congruent pieces. So that'll be useful as we go along. I'd recommend you draw the perpendicular part and the congruent markings on the right side. So if you're quizzing yourself, you can see the markings on here, but not on the left side. So you can kind of fold your paper and quiz yourself. The next type of triangle we're going to look at are equilateral triangles. And you might think equilateral triangles are even more easy because all three sides are congruent, which means all three angles are congruent. That's true. In fact, we can find out a little bit more information because everything is the same. We know from 8th grade that the angles of a triangle add to 180 degrees. This might be described in your book or in other places as the triangle angle sum. Because of that, because all three angles are the same, we can say that we're doing x plus x plus x, or more efficiently, 3x, is equal to 180 degrees. And from that, you can figure out that all of the angles of an equilateral triangle are always 60 degrees. Now here's a more complicated exercise that's in your book, number 30. I've recreated the diagram on the left. Here, we can start by using some information. They tell us that the measure of angle ABC is 114 degrees, and they ask us to find the measure of angle BAD. Look for those in your diagram. Next, I made a list of things that I know. we have the given angle ABC is 114 degrees. I also added that triangle BCD is equilateral, which means the measure of angle DBC is 60 degrees. I also added that the angle, or the triangle BAD, is isosceles, because it has two congruent sides, which means the measure of angle BAD is congruent to the measure of angle BDA. Next, I figured out what is the measure of angle ABD, so the vertex angle of the isosceles triangle. And using a little subtraction, we figure out it's 54 degrees. Next, I redrew just the isosceles triangle. That helped me create an equation 54 plus 2x is equal to 180 degrees. From that, I was able to figure out what x is, and x is going to be the same as the target angle, BAD. The last theorem we need to know a little bit about before class is the exterior angle theorem. Here, I've drawn a picture, and you can see the measure of BCD is an exterior angle of the triangle. It's made up of a ray extending from point A through point C, and eventually through point D. Now, that angle, because everything keeps adding up to 180 degrees, and because it makes a linear pair with angle BCA, you're going to find out that that is actually equal exactly to the two opposite angles inside of the triangle added together. And we'll work with this a little bit more in class. All right, write down your summary and get ready for some questions to ask in class.